Hi, I'm Jocelyn, and I'm presenting the Dynamic Playlist Generator on behalf of my Project Studio team with team members Rose, Gus, and Ananya. Our project, the Dynamic Playlist Generator, is a web application that creates musical playlists based on contextual data. The intended market for this application is the restaurant industry. With the app, restaurant owners will benefit from personalized, adaptive playlists that should enhance consumer satisfaction while maintaining autonomy from the restaurant owner. From preliminary research, we found that a restaurant consumer's experience can be improved with music. Under different musical conditions, consumers may spend more money, eat at different speeds, and may have enhanced impressions of a restaurant's quality and authenticity. Despite the relationships shown between music and food consumption, the restaurant industry has not fully realized music as a resource to boost consumer satisfaction and sales. Often, restaurants play through top hits and do not take the time to craft personalized playlists. Currently, there are a few products in the market for playlist generation for businesses, and those available are relatively static. Our application tests a more dynamic approach by not only capturing a user's static preferences, but also by capturing the noise of a restaurant to influence the selection of future songs. The app relies on user input, the Spotify Web API, and a library of songs with associated metadata. Users define a list of parameters that map directly to categories within the available metadata, such as genre, mood, timbre, instrumentation, tempo, and danceability. A subset of the total library is created based on the user's preferences. The songs are queued dynamically, and only the current and next songs are shown to the user. The user chooses how songs are added to the queue. Room noise selection maps the average sound pressure level during the previous song to tempo. When the sound pressure level increases, faster songs are queued, and when the sound pressure level decreases, slower songs are queued. Similarity selection chooses the song that is most similar to the previous song based on the available feature space, and random selection queues songs using random number generation. Now let's see it in action. We'll start by demoing the random selection mode. When the app is launched, the user sees an About page prompting them to log into Spotify. After logging in with their Spotify Premium account, the user is taken to the application's main page. Here, the user sees a series of questions asking about their restaurant and their playlist goals. These fields are mapped directly to the library metadata to create the song subsets. The user has many options when choosing their playlist. They can select multiple genres or multiple moods, and even choose no preference options. The final question sets how the queue will be played. For now, we'll select random. After completing the form and waiting for the queue to load, the user will see the first and second songs in the queue. They can play the first song by pressing the play image. Now the album art is displayed and the song is playing. To pause, the user presses the album art. The user can change their playlist at any time by pausing and updating the form and resubmitting. After resubmitting, a new playlist will be made reflecting their changes, creating a new song subset, and updating a new queue. Now we'll demo the similarity selection mode. The user fills out the form as before, but this time selects No Play Similar Songs for their final question answer. In doing so, a new subset will be created and the queue will be populated with similar songs. The first song is a random pick from within the subset, but the second song is the most similar song to the first song chosen. Let's look at the data to see that the first and second songs are similar. The metadata for the first song is on the left and the metadata for the second song is on the right. At face value, it is hard to tell how similar these songs are, but when we look at the similarity matrix and calculate the rate of similarity, we see that these songs have about a 97% similarity rating. Now let's look at SPL selection. Again, the user fills out the form and selects Make My Playlist Awesome to use SPL. The SPL is recorded with the default microphone and can be seen in the top left above the album artwork. For the sake of time in this demo, I will show the covers of 3 songs that were selected by the SPL selection method. Additionally, for this demo, the SPL level during song 1 was kept between -30 and -40 dB. The choice of song 3 is determined by the average SPL level of song 1. Song 1's average SPL level is mapped to the tempo values of the remaining songs in the subset using a Gaussian distribution, and the song with the matching tempo value is added to the queue. Here we can see the tempo data for songs 1, 2, and 3. We also notice that, as expected, the tempo for song 3 is lower than that of the previous.